When you're dealing with a game that is split into several exe files, and obviously these exe files have to communicate with each other, luckily on MS-DOS you can just leave something in memory, then another executable, when it starts running, can just read from that portion of memory and it will be untouched. Now, and that way, one executable can write something into that region of memory, and the other executable can then read from it to see what the first executable wanted from the second executable. Now, the date, and this is something called resident data, and resident data is stored in a specific format, and that format is actually different for all the PC98 Toho games. This is an example of a resident structure from Toho 3. So the resident structure begins with an ID string. The ID string is used in order to find the resident structure in memory by master.lib functions such as resDataExist. Obviously, master.lib can also create resident data with a function called resDataCreate. Now, if you're wondering how the games know where the resident data is located in memory, they store the pointer to the resident data in their configuration file. So here we have the ID string. Now, the executables, all of the executables need to know which difficulty you started the game at. So that's what this field is for. Now, playCharPalleted, this is the byte that indicates which character both you and the other player, be it a CPU or a real human, use. Obviously, the first player can also be a CPU. Now, the format of the ID of the player characters is a bit special in that it's not like a number from 1 to 10, I think, if that's how many characters Doko 3 has, but rather it's in the same format as the playCharPalleted field in player.h, and playCharPalleted in player.h is just the ID of the player character, right shifted, no, left shifted, then one is added. And that's the same format that's also used here, and we obviously have two because Toho 3 is a multiplayer game with two players. Now here we have, this is actually a boolean, whether or not the player is a CPU. If the first element of this array is 1 or true, then this means that the first player is a CPU and its inputs or its movements are based from decisions of an AI. If that is 0, then its decisions and movement is based on the input of a player. Now here we have the random seed. The random seed is a long because it's 32-bit. Now that's actually a pretty nice meme, and that is that the PC98 games, which are 16-bit, use a 32-bit RNG seed. Meanwhile, the 32-bit Windows games actually use a 16-bit RNG seed, which means that only a very small fraction of the possible values of RNG can be reached in Windows games. This one is unused. Probably something related to debug. Now this is the music mode. The music mode is 0 if music is disabled, or 1 for one type of MIDI synthesizer, and 2 for another type of synthesizer, and so on and so on. This will tell this is set to true if you game over. That way main.l.exe knows whether or not it should display the game over screen or proceed to the next stage or restart the current stage. Score le BCDT. This is a special structure. This is actually also its own structure, and that is score le BCDT. This is just an array of bytes where each byte is a digit of the score counter. The PC98 games don't store the score as just one number, but rather each digit is an element of an array. Then the game mode. 1 is story mode, 7F is demo mode, 80 is player versus CPU, 81 is player versus player, and 82 is player versus CPU. Any game mode that's 0x80 or higher is a versus mode game mode, and it's 0 when you start the game up, and the game never set the game mode. Story opponents. When you play in story mode, this is the array that in which the character IDs of your opponents are stored. Stage ID, the ID of the current stage you're in story mode. the amount of lives you have, whether or not you beat the story. This, if this is set to true, then op.exe will open up the name registry. But this is not the only thing that actually has to be set to true in order for op.exe to do name registry. Then, the amount of credits you have remaining, the game doesn't store the amount of continues you use. Instead, it subtracts 3 from the amount of credits you have when the game ends in order to show the amount of continues. Then, if this is set to true, then op will run a loading routine that is faster, and if this is set to false, then op will run a loading routine that is slower. And every second time, op will load in a fast way, and every second time, op will also load in a slow way. Then this is the variable that keeps track of your skill that then gets displayed at the end. And this is the flag that indicates whether or not the demo is active or not. And note that it doesn't actually get reset to 0 immediately when the demo finishes, only when you start up story mode or start up the versus mode. But it only gets set to 1 by the demo mode. So this is just a rough overview over this residence structure. Obviously, if I open up another residence structure, it's gonna look different. Here we have resident.hp of THO4, and obviously this is completely different and also a lot larger, and there are 182 unused bytes that are still part of the structure. You can also check the THO5 resident.hpp, which is a bit different, actually a lot different. And that's basically residence structures. Now the reason I made this video is because NMLGC actually changed the link to me on his blog about REC98 to my YouTube channel.